Hi guys, so today we're going to be starting a new unit known as trigonometry, which many of you may have heard of. It's a part of the CIM and AdMath courses that everyone is expected to know. However, some parts of it pertain more to AdMath students who will do more complex problems than CIM students. In this video though, however, we will cover basically what even is trigonometry and how we can use it in a few basic examples before we get to harder problems. So trigonometry is basically, I think of it as a bridge between angles and sides of a triangle. So the tri obviously comes from 3, which is from a triangle as well. So if we think about, let's say this triangle over here with a 90-degree angle, so the angle theta, I'm going to name it theta, can be expressed in a variety of different ways. So when we look at right-angled triangles, there are 3 main trigonometric functions we can take note of. So those are sine, cosine, and tangent. And these are kind of like the 3 main parts of trigonometry. So let's first talk about what they are, and then I can show you how it works on the triangle itself, so it makes more sense. So sine is basically the opposite over the hypotenuse. So if we take our triangle over here with angle theta, and let's say we just took a regular triangle, 3, 4, 5 triangle. So 3, 4, 5 you may have heard of because it's Pythagorean. So 3 squared plus 4 squared is 25, and you square root it and you get the hypotenuse, which is 5. So we can express sine by the sine of this angle using these side lengths. So in this case, the opposite of this angle, so the opposite side, is the 4. And the hypotenuse is the diagonal, of course. So this, in this case, would equal, so sine theta would equal 4 over 5. And this is obviously just a representation, doesn't really tell us much at the moment, but when we get to problems, this will have more meaning. The cosine is the adjacent over the hypotenuse. So the adjacent is known as like the side that's next to the angle. So in this case, it's this over here. And the hypotenuse, as usual, remains to be 5 in this case, so cosine of theta would be 3 over 5. Now the tangent is the opposite over adjacent. And in this case, we know the opposite is over there and the adjacent is this one. So we get 4 over 3 for tan theta. Now we don't actually know what theta is right now. Theta has a value that we don't know. We can express this as sine theta is equal to 4 over 5, and cos theta is equal to 3 over 5, and tan theta is equal to 4 over 3. There is a specific value of theta that can be generated based on this. And we can actually find this out by using the inverse function. So on our calculator, we have a sine to the power of -1 function, a cosine to the power of -1 function, and a tan to the power of -1 function. It just means the inverse of sine. So the inverse of sine of 4 over 5 will give us the angle. So let's just do that right now. That gives us 53.13 degrees. Then we can do the same thing with our cosine just to check our value. It should still give us the same value. 3 divided by 5. Yeah, and our angle is still 53.13. And just like that, just by knowing the side lengths of a right angled triangle, we're able to deduce that theta is equal to 53.13 degrees, just by these ratios over here. Now, we can also apply this to triangles that are not right angled, but those have specific rules and regulations that we have to follow later on. But sine, cosine, and tangent can effectively be used in most problems to link the sides and the angles together when we're not given much information otherwise. Because otherwise, how would we find this angle by just knowing the side lengths? That's right, you can't. You do have to use sine, cosine, and tangent. Okay, so I've just written the trig identities that we have so far at the top left. So sine is equal to O over h, or opposite over hypotenuse. Cosine is equal to A over h, or adjacent over hypotenuse. And tangent is equal to O over A, or opposite over adjacent. So we're given the following information. So we have to find x and h in the right triangle below. So we're given that theta, our angle, is equal to 51 degrees. And the opposite of theta, so we just look to the opposite side, and that's 10. So opposite is equal to 10. Then our adjacent is equal to x, and our hypotenuse is equal to h. And we're asked to find x and h. So I would just like to first point out that there are many ways of doing this question. So you also know that this is 90 degrees. So hence, because all the angles in a triangle add up to 180, you know that this here is 39 degrees. And you could look at it from that perspective. Look at this as your theta. You could say, oh, well, the opposite of 39 degrees is x, and the adjacent is 10. And then you could use different methods to solve for x and h. This is just the most apparent way. So based on using 51 degrees, I'm just going to erase the 39 degrees over here. Based on using 51 degrees, we have the opposite, but we need to find the adjacent and the hypotenuse. So based on the fact that we have the opposite, we can actually use the two equations on our top left board of equations in order to solve for h and x. So sine and tangent are applicable here because they both contain the opposite, and we only have one variable that we need to solve in each of these instances. So what I'm going to do is first find the hypotenuse. So we know that sine of theta, which is 51 degrees, is equal to the opposite, which is 10, over the hypotenuse, which is h. If we do a little rearranging, we get h sine 51 is equal to 10. So h is equal to 10 over sine 51. And if we put that into a calculator, we get 10 over sine 51 is equal to 12.87 to 2 decimal places. And I'm just going to assume this is cm, although they haven't actually directly specified what unit is being used. Then you have, we have the tangent equation. So tan 51 is equal to the opposite, which is 10, over the adjacent, which is x. If we do some rearranging, we get x tan 51 is equal to 10. So x is equal to 10 over tan 51, which is equal to, and I'll just put this into my calculator, tan 51, which is equal to 8.10 to 2 decimal places as well. So as you can see, we've been able to obtain x and h just by using one side length and an angle in a right angle triangle. And this is one of the fundamental uses of trigonometry, in that it can connect sides and angles together in a very simplistic way. So as you can see, it only took one or two identification of equations in order to solve this. So we're going to move on to one more example before wrapping up this introductory video to trigonometry. Alright, so let's take a look at this problem over here. So BH is perpendicular to AC. So to find x, which is the length of BC. Now, a common misconception is that we look at this diagram and we're like, oh, it's isosceles. Because it could be, this diagram, even though BH is perpendicular to AC, doesn't make it an isosceles triangle overall. Because it could be drawn like this, where this is the perpendicular line. But this and this length are nowhere near the same. So let's not fall into that trap, and let's do this in a way that guarantees our answer is correct instead of making assumptions. So what we want to first do is figure out what this length is over here, because we're given that the overall length is 19, but if we know what this length is over here, we know what this length is over here, since it's a straight line. And we can therefore find x, which is the value we want. So to find AH, which is the value we want in question, well, we need to first identify which one we need to use. Do we need to use sine, cos, or tan? So we know that the angle theta is 39 degrees, and that the opposite to theta happens to be 11. But we want to know what the adjacent to theta is, the side next to theta, which is AH. Now we have the opposite and we want to find the adjacent. So tangent seems like a very, very viable way to go. So we know that tan 39 is equal to the opposite over the adjacent, which is, not x actually, I'm going to name it a. This length is a. So a is equal to 11 over tan 39, which is equal to, and then let's put this into our calculator, tan 39. And that gives us 13.584. Now we know that HC is 19 minus 13.584. So 19 minus 13.584 gives us 5.416. So HC is 5.416. But we're not done yet. We need to first figure out what x is. So to do that, let's find out what this angle over here is. We're going to name this alpha. And we know what BH is, which is the opposite of alpha, and we know what HC is, which is the adjacent to alpha. So using this, we can actually solve for alpha using tangent. So tan alpha is equal to the opposite over the adjacent, which is 5.416. Now, if you use the inverse of tan to negative 1 of 11 over 5.416, we get a, which is equal to, let me just put this into my calculator, 11 over 5.416, which is equal to 63.8 degrees. Now we have all the information we need to solve for x. So since we have the opposite of alpha, which is 11, but we want to find the hypotenuse, we can do, you can use sine. So sine of alpha, which is 63.8, is equal to the opposite over the hypotenuse. So x, which is the hypotenuse, is equal to 11 over sine 63.8, which is equal to 12.26 cm. So overall, through this way, we've shown that trigonometry can be immensely useful in connecting sides and angles and ensuring that even if we don't have that much information, we can still solve problems. It's actually a very important concept in both CIM and AdMath, so it's worth definitely studying and keeping in mind. In the next video, we'll cover some slightly more difficult problems to do with trigonometry and also cover how it can be used in non-right angle triangles. Thanks so much for watching and see you in the next one.